Now, PR is a way for us to adjust the pulse generator setting. This is the sensor. Now, this sensor, we actually call it a pulse generator, and this is actually a straight probe, as we have mentioned earlier. Once we have pressed this F2 button, by pressing this dam, right, we are actually adjusting the acoustic the acoustic impedance, so that by changing it, you may see there's a difference in terms of the amplitude, the width, and also the resolution of the pulse. Okay, and whereas for this rectifier, we're actually adjusting the pulse display. Now, what is called this pulse display? Should we actually in full? Okay, probably let me explain. Let's start off with this positive. This is called positive. When we select this positive, it means that we actually only use this positive half of the pulse for the evaluation. Okay, and negative means that we actually only select the negative cycle of the pulse, then we just flip it over. Okay, as you can see now. And what about to the full? To the full means we use both. We use both cycle. That is to say that this negative one we actually also flip over. Then positive and negative is actually overlapping each other. Okay, the next one is actually radio frequency. And what is radio frequency? It looks exactly like this. There is actually a full radio frequency pulse. Alright, but seldom we use it. Normally we will just use positive or negative. That would be good enough. Okay. Now, the next one on this filter. Filter is actually a selection that we select this frequency range, 0.1 to 1 megahertz, 0.5 to 4 megahertz, or 2 to 10 megahertz. And for my this angle probe, it's actually showing 5 megahertz, meaning I should select this 2 to 10 megahertz range in order to suit it. Then how about for my this straight probe? My straight probe is actually 2.5 megahertz. I can either use this filter range or I can use this 0.5 to 4. Alright, correctly selecting it will have optimum display of wave. Okay, now what is this reject? Now this reject it's actually, sometimes there's a noise when we actually measuring the waveform. Say for example, right now I actually increase the gain. Now there will be many noise actually came in. So by introducing this reject, what does it mean? It will reject the noise. Okay, so I actually increase it, right? You may see this noise, small noise will actually be reduced. Okay, however, do not use this reject so easily. Why? Because we may reject the signal that we actually wanted to see. Okay, so usually we just leave it to 0% unless for some special case. Now, to proceed further, we press another one more time this PR selection, the probe selection. Now, what is this datum line? When we select this datum line, we're actually moving this reference point of this waveform display. That's all. The horizontal display. Either we move it down or lower. Okay. Usually we just leave it at 0. For probe type, now it's actually very important. So if we select the wrong probe type, we may not get any display of this waveform. And the correct setting for both straight probe and also this angle probe is PR. PR stands for single crystal probe. Okay. So what happens if we select dual? Nothing will display. True, there's nothing will be displayed. So only when you select the PR, the single crystal probe, only then you will have this display of waveform. Now, what is this PRF? PRF is actually a setting of frequency of updating of this information. You may see the higher is the reading that I actually tune up to, the faster is this capturing rate, meaning flickering, alright, to display the information. But usually for our type of display whereby the reading doesn't change very much, we just take it to 10, 20 or 30, that is good enough. Now the last one, this button, 2-point calibration, seldom used unless you all have this standard block for calibration. All right.